In this module, we will dive into the visitor pattern. A visitor represents an operation that has to be performed on the elements of an object structure. I'm Kevin, and throughout this module, I'll teach you what that means. We'll start by describing the visitor pattern. For that, we will use a real-life example, calculating discounts for employees and customers. After that, we will map that to a structural example and implement it in a demo. We will also implement a variation of the pattern. We'll continue with learning about use cases for the pattern and pattern consequences. We'll end the module by looking into related patterns. Let's continue with describing the visitor pattern. The visitor pattern is a behavioral pattern from the Gang of 4 library of design patterns. Its intent is to represent an operation to be performed on the elements of an object structure. The visitor lets you define a new operation without changing the classes of the elements on which it operates. That definition requires some further explanation. Imagine the following use case. You're building part of an order management system. You've got a large set of objects, but they're not all the same. You've got an internal customer class, a government customer class, a private customer class, and so on, all deriving from customer, but all with their own custom behavior and properties. At a certain moment, a requirement comes in to add new behavior to all these objects. You need to calculate a discount, depending on the amount of money the customer previously spent on orders. To add this behavior, you can implement it in all these classes, or depending on what needs to be known about the customer, you could implement it in a base class. But there's other types as well. Let's add an employee class to the mix. Employees of companies also get discounts, but the calculations for these are completely different. They are based on the amount of years someone is employed. Employee and the customer don't have the same base class, so we cannot use that approach anymore. We can, however, still add the method to calculate the discount on the concrete employee class. Yet, what if after some time a new requirement comes in? You now need to calculate some shipping costs for each customer and for each employee. And after that, you need to add JSON export to all objects, and so on. This becomes cumbersome. You always need to change these classes, which is risky. Also, we need to start wondering whether it makes sense to have all that added behavior in all of these classes. Maybe it doesn't belong there, if we keep the single responsibility principle in mind. Enter the visitor pattern. This allows adding behavior to classes by adding the behavior to another class, the visitor, which will visit the original classes and execute that behavior. To avoid overloading the screen with a huge diagram, let's just stick to a customer class and an employee class, unrelated to each other and with their own properties and operations. But there can of course be many more classes. They have a discount field which we will calculate using our visitor. We have both of them implement an interface, the iElement interface, which defines one method, accept. This method accepts a visitor, or rather an iVisitor, as we want to work on an interface here. On that interface, we define a method to visit a customer, which accepts our customer, and another method to visit the employee, which accepts our employee. In other words, one method per class, so the discount can be calculated correctly, as the algorithm may be different for each class. A concrete class, discount visitor, implements the iVisitor interface and contains the actual logic to calculate the discounts. The last thing we need is some sort of object structure that accepts our discount visitor and is responsible for running through the customers and employees and passing the visitor through to the accept methods on them. This can be a list or a composite, depending on your use case. Let's say that for our case we will name it container. And with that, we've got our visitor pattern. Let's map this real-world example to the pattern structure. We'll start with the element, which maps to our iElement interface. This defines an accept operation that takes a visitor as an argument. Then we've got concrete element implementations. These are our customer and employee classes. A concrete element implements the accept operation that takes a visitor as an argument. The object structure then can enumerate its elements. It typically provides an interface to allow a visitor to visit its elements, and it can be a composite or a collection. As you've guessed, that maps to our container. Up next is the visitor, which maps to iVisitor. This declares a visit operation for each class of concrete element in the object structure. And then we've got concrete visitors. We've got only one, our discount visitor, as we learned in the previous clip, but others are possible as well. These concrete visitors implement each operation declared by the visitor. So they contain the actual algorithm. Often they also contain state that accumulates while traversing all the objects, which can be useful for callers, like storing the total amount of discount given. And with that, we've got our pattern structure. Time to implement our example in a demo. In this demo, we will implement the visitor pattern. Let's start with our concrete elements, the customer and employee classes. We will give our customer and employee a name. The way discounts are calculated for these are different. For the customer, it's 10% of the total amount ordered, so we add a property for that. We also add a discount property which will be set by the visitor. Therefore, the setter cannot be private. We want to ensure that a customer is constructed with the amount ordered and name passed through, so we add a constructor to that avail. Likewise, we create an employee class. For an employee, the discount will be calculated depending on the amount of years the employee has been employed. Up next are two interfaces, the iVisitor interface and the iElement interface. Note that these can be implemented as abstract-based classes as well, if you wish to provide some out-of-the-box functionality. For our use case, that's not applicable. Let's start with the iVisitor interface. As we learn on the slides, it needs methods to visit our concrete elements, visit customer and visit employee. The iElement interface then contains one method, accept. That method must accept an iVisitor so it can visit the concrete elements and execute its algorithm on them. Our concrete elements must thus implement this iElement interface. So let's do that next. Let's scroll back up to our customer class. We have it implement the iElement interface, leading to an accept method on this customer class. The iVisitor gets passed through via the accept method. So what we can do now on this iVisitor interface is call visit customer, because that was one of the methods that was created on it. We pass through the customer object itself, so the visitor has access to the customer properties it needs to do its calculation. Also, for demo purposes, we write out some info to the console output window. And we do something likewise for our employee class. We implement the iElement interface. That leads us to implementing an accept method. iVisitor gets passed through, so on iVisitor we can call visitEmployee, passing through this, the current employee object. Here too we write out some info to the console output window. We haven't got an actual visitor yet though, so let's create that next. We'll name it discount visitor. It must implement the iVisitor interface. That means we need to implement two methods, visit customer and visit employee. In the visit customer method, we can calculate the discount for a customer. 10% of what the customer ordered. The visitor accesses the customer properties it needs, and it also changes the customer object. It sets the discount. So, visitors can change values on the object they visit. But they also often store information about their operation results that can be useful for callers. So let's add a property to our visitor, total discount given. It will contain a summation of the discounts provided across all elements. So that means that when we visit a customer and we calculate the discount, we add that to our total discount given property. For employees, the calculation is a bit different. When someone has been employed for less than 10 years, a €100 discount is given. Otherwise, a €200 discount is given. Here, too, we add the discount that's given to the total amount. Lastly, we need a structure to hold employees and customers. That's the object structure from the pattern structure. We name it container, and it's a pretty straightforward class. It stores lists of employees and customers, and it allows passing through a visitor to each of them. This is thus a composite. With that, our pattern implementation is done. Let's write a bit of code to test this. We new up a container. For that, we need to import the visitor namespace. And then we add a few customers and employees to it. For these, the discounts will be calculated. We new up a discount visitor, pass it through to the container, and write out the gathered amount of discount given in total. Once the discount visitor is passed through, it will visit all our customers and employees, which means that once we reach this last write line statement, total discount given should effectively contain the total discount given. Let's add a read key statement. And let's give this a try. And there we go. As we notice, all employees and customers were visited, discounts were calculated by the discount visitor, and all these discounts added together results in a total discount given of €530. So there we go. But are we there yet? Let's study a potential issue with this implementation and the solution in the next demo. We're looking at our iVisitor interface. One of the issues with this approach is that this interface needs to be changed whenever a new concrete element is added, because it contains methods that work on these concrete elements, like customer and employee. To avoid that, this interface is often simplified. Instead of having it contain methods for each concrete type, we have it contain one method, visit, that accepts an iElement instead of a concrete implementation. All our concrete implementations have to implement iElement anyway, so this should work. But it also has consequences. First of all, we need to make a change to our customer and employee classes. In their accept methods, it's now the visit method that needs to be called. We will also have to change the discount visitor itself. If we implement iVisitor now, we see we only have one method to implement, visit. So that means it's up to the discount visitor to check the actual concrete type of the element, so it can execute the correct logic. So we adjust our old methods by making them private. And in our visit method, we check for the actual type and depending on that, execute the correct algorithm. No need to change anything to the client. That should still work as before. So let's give this a try. And there we go. Still works as expected. We've made our interface simpler, so we won't have to change that whenever a new concrete element is added to our object structure. Yet we have introduced additional logic in the visitor implementation. It's this implementation I see more often in the wild, but both implementations we made are valid. The intent remains the same. It's just a template that's changed. Let's have a look at the use cases for this pattern.